Alright, section 4, reflections and recursion. Introduction. You already know this, right? Recursion is the process of defining an element in a succession based on the prior elements in the sequence. Alright? In other words, something that is defined recursively when it is defined in terms of itself. Right? We've been studying recursion for a while now. You know this, right? Okay. This is a real life example I created for you. Laptop, mirror, infinity. Okay. Imagine placing your laptop. Should I draw this or should I just show it like this? I think I'll draw this. It will be better. I hope you understand my drawing. Okay, how do I draw 3D? Like this. Something like this. And this is the floor. Oops. Whatever. So this is your laptop with its front camera on. And this is the mirror. Okay, they're in front of each other. Now, the mirror shows what it sees, right? That's called reflection, showing what you see. And it sees the laptop with its front camera on, right? Now, the laptop with its front camera on also shows what it sees. It can also be said reflective, but you know, it's not technically, but yeah. So it shows what it sees, and what it sees is a mirror. It sees a mirror which shows a laptop with its front camera on. Now, what does the mirror see? It sees a laptop, but in that laptop sees a mirror, and that mirror sees a laptop with its front camera on. And then it keeps going back and forth, back and forth, back and forth infinitely. Right? I hope I made it clear. Okay, it was difficult. I'm recording this for 5th, 6th time now. This same analogy. So, I think you got it, right? It's repeatedly reflecting. It's easy to think about, but I wanted to make it clear to you with a drawing. I hope you got it. So that is what's happening. That can be seen in my picture. I stood in front of the mirror and took this image. Now what the mirror is showing is my laptop. Okay, that's it. That's all it's showing. But my laptop is showing the mirror again, which is showing the laptop, which is showing the mirror, which is showing the laptop, and it's reflecting back and forth again and again. Okay, got it? Now, turning it into simple code. Now, codes don't always have to be detailed till the very last, very basic level. Sometimes when turning real life examples to recursive codes or code of any matter, code of any kind for that matter, you have to use some layers of abstraction. That reflect in mirror is something. That's something I don't care about how it actually happens, but what the main thing is reflect in mirror. You can say that. Now, definition of reflect in mirror in this case is reflecting in mirror again. You can say that this entire scenario is reflect. This entire thing is a function which is reflect, and what it does is it calls reflect. So, and when it happens whenever you do this thing. Whenever you stand with your laptop's front camera on in front of a mirror, this is what happens. If you want to represent it programmatically, this is what happens. Your mirror says, okay, I'll reflect. Now, what it reflects is your laptop screen, which also has the function reflect. Now, this reflect, what it does, it reflects, and that reflect again reflects, and it keeps reflecting again and again till infinity. Okay? So in this code snippet, the function reflect in mirror simply calls itself without any base case, without a condition to stop the recursion. This leads to an infinite loop, an infinite function call, much like an uncontrolled series of mirror reflection. Okay, when the function is invoked, it enters a perpetual cycle of calling itself repeatedly. In each iteration or in each function call, a new instance of the function is created and the process continues infinitely. I hope you got it. Now, okay, is it really infinite though? When exploring the concept of infinite reflections in mirror, we encounter a fascinating interplay between technical infinity and practical limitations. In the context of recursion, especially when visualized through mirrors like we did in the example before this, we can draw parallels to crucial concept of a base case. Like there really is not a base case. It's going on infinitely if we see it, if we talk about it, like in theory. But in reality, it's not like that. We can add an interesting twist. To bring order to this infinite loop, we introduce a practical consideration. the clarity of laptop screen reflection in the mirror. Now you may see that here the reflection is theoretically happening infinitely, but you can see me only thrice. So what's useful to you in this practical situation is only 3 reflections, right? You can see me once, you can see me twice, you can see me thrice, and that's all. That's all there is. Then it's just some unclear image. The image is not clear anymore after that. So you can say that that is a base case. When the image is not clear anymore, you can say the reflection has stopped. Okay, the recursion has stopped. So this is what's written here. The recursion in mirror reflections could be said to have a base case that if the reflected laptop screen becomes unclear, the process stops. This is akin to introducing a base case in recursion, a condition that when met halts the recursive process. Alright. Now there are 2 factors influencing the base case. This is the sun, which represents brightness, and this is just an image I put to scare you away. Here, don't worry, this image is just for humor purposes. So yeah, brightness of the screen. If the screen's brightness is too intense, it can overpower the reflections, making them less distinct. Okay, this can also be a case for base case for our recursion or reflection. Because if the laptop screen is too bright, like full brightness, and you keep it in front of a mirror, then there are chances that the mirror will just reflect everything it sees, and in the laptop it's just white plain flash. So there is no recursion after that, right? So if the laptop screen is too bright, then also there will be a base case. Or if it's not bright at all, then there will also be no recursion because nothing is reflected. So there needs to be a moderate brightness and size of the image, because if the image keeps getting smaller and smaller and smaller and smaller, you won't be able to see it after a point with your naked eyes, of course. So translating it into a recursive code with base case, you can say that reflect in mirror or reflect or this entire thing is a recursive code, and the base case is that if not clearly visible on the screen, right? If it is not clearly visible on the screen, you can return, otherwise reflect again. And whenever it will reflect again, it will again check. If not clearly visible on the screen, return, then it will reflect. Okay, got it? Let's understand this code again. Reflect in mirror. This function represents the act of reflecting, simulating the recursive nature of reflections in the mirror with a laptop camera, just like we saw. Now we said that we will introduce a base case which is clearly visible on the screen. Now this is called abstraction. You just said there is a function which means clearly visible on screen. Now you did not say what are the variables in that, what is the exact functionality, but you know that the reader knows what this means, right? This is abstraction. You just said that this exists. So in the context of laptop camera and mirror, this function checks whether the image of the laptop screen is clearly visible in the mirror or not, just like the name suggests. This mirrors the real world scenario where we assess the clarity of laptop screen's reflection, right? Breaking this code down, or I know that's not a word, but yeah, base case. Just like we said, if not clearly visible on the screen statement serves as our base case, and the recursive call is else reflect in mirror, because it reflects again and checks is it clearly visible on the screen, otherwise reflect. And when it is not clearly visible on the screen, if not clearly visible on the screen, then return, and it will return, and the reflection will end. Okay, so in our case, what happened, should I tell you, like by drawing this? Actually, you know what, I kept this drawing here only, do not erase this, because you can see here also that after 3 reflections, we were unable to draw it. So in this case, this could be a base case that when you are unable to draw further, then you cannot explain it. And in this explanation thing, this is the base case. In the real world, when the image is not clearly visible, that is the base case. So here what happened was the reflect in mirror was called and the image was clearly visible. So again reflect in mirror was called. The image was clearly visible. So again reflect in mirror was called, but this time the image was not clearly visible. So it returned. And what return means n. So it reflected 3 times properly, and then we said no. Now reflection is not happening because we don't consider it as reflection if the image is not clearly visible. Okay, I hope that was the last slide. Right, that was the last slide. Yep. Okay, so I hope it was easy, simple, and you got it. If you still have any doubts, you can ask me. Your one question on DA is based just upon this. You also have to click a picture like this or something. And other question I made with a real life case. I took a real life scenario and then there are some questions on that, and you have to, just like we converted this into a simple code, you have to convert that case also, that real life scenario also, into simple recursive code. You'll have to think about it. It's an interesting question, and it is something that you can like actually, because it will make you think. Okay, so have fun and approach it. And if you still can't solve that question in your DA, just at least try to approach it and just write your approach. Okay, that what you understood by it, how can it be solved, whatever you understand, just write. Okay, all right, make efforts, have fun, and learn. Okay, that's what you're here for, right? Right then, section 4 and see ya.